The Charter Podcast, Episode 10, Code Red for Humanity, Part 2, The Transition to Clean Transport, with Professor Juliana Early of the School of Mechanical and Aerospace Engineering, hosted by me, Maurice McCartney. In the first part of this series, I spoke to Dr. Donal Mullen about the IPCC report launched in August 2021, described as a Code Red for Humanity.
The IPCC very clearly stated in the last report that unless we make deep reductions in carbon dioxide and the other greenhouse gases, then we are going to exceed 1.5 degrees almost certainly.
In this episode, I talked to Professor Juliana Early of the School of Mechanical and Aerospace Engineering at Queen's about the report and about her research on clean propulsion technologies and clean transportation systems, starting with a discussion of electric cars.
In terms of the IPCC report, it's been great to see the kind of Code Red for Humanity button being pushed and kind of really trying to catalyse a lot of the need for more than what we're doing today. But I mean, in terms of kind of the car sector and in particular kind of the pure battery electric car, because when you hear electric cars being talked about, there is a lot of confusion because plug-in hybrids tend to end up getting kind of thrown into the mix of electric vehicles. Whereas I think for a lot of people, when they're looking at clean technologies, clean propulsions, they're really talking about the pure electric drive, no internal combustion engine there instead. So there's always a little bit of smoke and mirrors there around the stats that come out, that when you actually dig in, it's battery electric plus plug-in hybrid. Whereas what I'm going to talk about here is going to be very much where we're going with the battery electric side. So if we take the kind of the UK dimension at the moment, in the last year, we've passed the kind of 250,000 cars which are an entirely battery electric powertrain on UK roads. And I think that's a really great accomplishment. It's a sign that we're going in the right direction. And about 7.5% of sales of new cars in the last year have been the BEV, pure battery electric technology to date. So there is traction and it is building within the kind of the local economy. And I think in the last year, despite kind of, COVID, where there was a big market depression, we've seen one of the biggest uplifts in EV registrations this year to date. So there is huge growth starting to be seen in that sector. A lot of that has been driven by favourable government policies within the UK, the introduction of things like zero and ultra low emission zones. And there is changing consumer attitudes starting to appear. They're starting to become more affordable. Some of the range anxiety issues are starting to be addressed. There's more financial incentive schemes available. And a lot of those have catalysed this increased growth in the EV registrations that we're seeing within the UK. I think we're also starting to see a lot of diversity in the battery electric vehicles, which are starting to become available to the market, which again is stimulating this kind of increased growth in sales and the manufacturers responding to the clear need within the market to make those available. So we're starting to see kind of large family hatchbacks appearing on the market, estates and SUVs. Again, you're starting to see the manufacturers changing what they're putting out into the marketplace in direct response to what the public consumer is wanting. Just to put that in a little bit of context, 2015, 5-6 years ago, there were only 55 variants of battery electric vehicles available on the market. And again, I'm talking about those ones where it's just the battery, it's a pure electric drivetrain. Today, we're up to 235. So there's been a huge amount of investment and there's been a big change in what the manufacturers are putting out there. If we then start to look at the commitments that are being made by the major car manufacturers, what they're doing is changing as well. So if we take the kind of the top 20, 18 of those have committed that they will be increasing their EV offering significantly. And there's been significant, very ambitious targets set around that. So if we take the likes of Volkswagen as an example here, they're forecasting that 70% of the European sales will be fully electric by 2035. And that's a big change from where there are today, where it's the other way around. That sales is largely their IC engine diesel alternatives. But, we do have some companies that are going more aggressive on those targets beyond that. We take Volvo as a really good example of driving the marketplace forward. They've said they anticipate that all of their vehicles will be electric by 2030. So there's a lot being done. But when we start to look at this in the kind of the global trend, we are seeing kind of uplifts. So we're seeing kind of the increases in UK EV sales. There's forecasts that there'll be 4.4 million battery electric vehicle sales by the end of this year, which is double what was seen globally in 2020. The downside of all of that is that that's largely focused around Europe and China. There's not the same penetration into other global marketplaces and not the same rapid uptake. So when we see a lot of those kind of really ambitious global targets being set on sales and development, a lot of them are focusing on the European market. It's not quite as ambitious and not quite as far reaching when we start to look at the North American market.
So there's some way to go in terms of the take-up of electric vehicles in the first place. I wonder, obviously the manufacturers can produce these vehicles nowadays, but there's also going to be infrastructural issues to do with charging points, to do with, if you live on a terrace with no garden or whatever, or no driveway, what do you do? So I presume there's also lots of things that not just the manufacturers have to do, but planners, local authorities. There needs to be a planning dimension to this, isn't that right? And an infrastructural dimension.
No, this absolutely needs to be a joint up approach. So if we think about some of the kind of biggest kind of pieces that you would see around the kind of the sound bites about why people won't take up EVs, range anxiety comes up as an exemplar, as a reason as to why the take up of BEV technologies has been as slow as it has been. Now, there's been a lot that's been done from the technology development side of things. Again, if we look over the last 5 years, about 5 years ago, the average range of a battery electric vehicle on the market was in around 200 kilometers. That's now moved up to closer to about 350 kilometers. And we have some that are setting up as high as 650 in the really high end, the Tesla Model S's of this world. So that has done a lot to kind of alleviate the concerns about the charging infrastructure. Where is it going to be? Because there's not necessarily the same pressure on, I'm going to need to be able to charge this at the end of the day, but there's still a lot that needs to be done. So change in this sector is not going to be driven just by people buying new electric cars. There's going to need to be infrastructure there that will support that mass transfer, if you want to call it that. And there's a lot of uncertainty around what EV charging points are going to be needed, where those are going to be located. Are we talking about at home, that you plug your car in at the end of every day at home? If you do that, where's the connections coming from? How much is that going to cost? It's more uncertainty. Where are they going to be on the road network? There's a lot of talk about, new street lamps with EV charging built into those as something that every street lamp will then become an EV charging point. But there's a lot of cost investment that goes in behind that. And there's still a bit of a postcode lottery today around, is there going to be an EV charging point available at your destination? Is there ones available in your local area? So we kind of look at things like Society of Motor Manufacturers and Traders is kind of a big umbrella organization. They did a little bit of work last year who were looking at what they believed was going to be needed in the UK moving forward to meet the needs for sustainable EV markets. And they were estimating about 1.7 million public chargers were going to be needed by 2030, and that raising up to 2.8 million 5 years beyond that, if we start to meet the kind of trajectories for transfer from internal combustion to electric that are being forecast. The cost of that somewhere in the region of about 17 billion pounds, which needs to be found from somewhere. And that doesn't mean that there hasn't been a lot of progress. The spending review last November did have kind of 1.9 billion committed to development of infrastructure, but that's a drop in the ocean if the public charging infrastructure requirements are in the order of 17 billion. So there's a big long-term ongoing rolling investment there to really make that happen. And I think just to put this in kind of the UK context in terms of the hurdles that we potentially have to overcome, if I look at Northern Ireland and look at us around us, we've got 1.2 million vehicles licensed on the road today, and we've got 337 public charging points. That's not an inconsiderable problem that we have on the horizon. And it is something that we really are going to have to address head on. There's no point incentivizing car ownership and promoting electric vehicles if the infrastructure simply isn't there to support it.
I suppose on a related note, the idea that we simply switch from petrol to electric and just keep driving private cars all the time for every journey is also perhaps something we'll need to look at. Obviously, as you said, there's investment from the manufacturers. There could be investment from the government in infrastructure and so on. But the other side of that might be improved public transport, and again, planning or cities and so forth better, so that there's a 15-minute city that some people talk about. I guess there's that. So maybe if you could tell us a little bit about what your take on the public transport side of things. I know you've been involved in some key research on hydrogen. Maybe just tell us a little bit about that.
So in terms of, you're quite right, and the whole drive towards replace an internal combustion engine car with a battery electric variant, and it just becomes more of the same, really isn't sustainable. We've got in-year continuous growth of volume and numbers of cars that are on the road, and that in itself is not sustainable. In terms of really looking at, if we want transport systems that are fit for purpose, we really need to look at the development of interconnected multimodal systems that are seamlessly interconnected, which are leveraging our public transport sector, our cycling networks, walking infrastructure, and not just focusing investment on high value rapid transport cars, new motorways, and so on and so forth. And obviously the public transport sector is one that would be fairly close to heart. In terms of kind of one of the roles that I hold in Queen's, I'm also the director of the WTech Research Centre, which is a strategic university industrial partnership with Wrightbus based up in Ballymena, who obviously are a bus manufacturer who are very much focused on driving the agenda in clean technologies within public transport. We've worked on a number of projects with them, really looking at how do you develop the next generation of electric powertrain that's going to transport 90 people around the city as efficiently and effectively and as cleanly as possible. And more recently, obviously, looking at the hydrogen domain. And that's been really interesting in itself, because a lot of the conversation around cars is battery electric and batteries on board, and the issues that are coming in with degradation, lifing, servicing, range, cost, affordability. But when we move into the heavy duty sector, we start to see more of an emphasis on the hydrogen-based technologies. And that leads to different questions around, when do you deploy a battery electric vehicle? When do you deploy a hydrogen vehicle? If you're planning a new fleet, as many of the operators across the UK currently are, it's what technology are they inserting where and why? And then behind that, coming back to your previous question, what infrastructure is needed around that? And that leads to a completely different planning process to what we would have traditionally had in that sector, where it's looking at the vehicle, the use case, what's available to it in terms of infrastructure around that, and a much more joint up planning process where you're looking at the operators, the manufacturers, the energy supply network, which previously wouldn't have been such a high consideration. You would have been, trucking diesel in. Now you're looking at, well, if this is my electric demand, how is that going to be managed through a local substation? If this is my hydrogen demand, where is that coming from? Am I going to manufacture that on site? Is it being ported in from somewhere else? So there are different questions and different challenges. And it actually makes it an incredibly exciting thing to look at, because it's now this big systems approach with a real potential for impact on public life, reimagining what the public transport sector will look like, how these vehicles are going to integrate in, and how do we work with emerging policies like the evolution of the ultra low and zero emission zones, which are really changing the shape and nature of how people move around our cities. And as you said, responding to that, being able to move through a city in 15 minutes, regardless of where you happen to be. That's not a small shift. It's not going to happen overnight. And it's going to need significantly more stakeholders than have ever been involved in those kind of public transport planning processes than we've ever had before. I mean, we have a number of projects running which are being funded by Innovate UK, the Advanced Propulsion Centre, and the Engineering Physical Sciences Research Council that are looking across these domains. And from my perspective, I obviously come from an engineering background. Up until maybe 5-6 years ago, I think it would be fair to say I worked with other engineers, whereas today I'm having more conversations with people who work in the medical domain, looking at public health impacts, working with people in social policy who are looking at kind of transition analysis, what the impact of these new technologies will be on the users of those services, and really starting to work in a much more interdisciplinary fashion than we've ever had before to actually address a lot of these challenges.
I wonder if a similar sort of take could be, a similar angle could be taken in terms of goods transportation. I mean, obviously we're talking about people, getting people around, but, if you're going to keep trading, we need to maybe try to learn to do that sustainably as well? Does the same technology apply there, and the same sort of thinking in terms of infrastructure, etc.?
Yeah, absolutely. And those conversations are already starting both locally within Northern Ireland and right across the UK, not just in terms of the heavy goods sector, but also how we start to service our off-highway sectors. So things like the dumper trucks, material handling, and the other components and vehicles that operate within city centres that will still end up being subject to the same emissions policies as we move forward. But there are big gaps which are still existing in those areas in terms of where are the power electronics, the battery technologies, the hydrogen technologies actually going to come from relative to how they're going to use them. The car sector has benefited from scales of economy, the sheer volume of cars, and therefore the sheer volume of investment that has gone into developing battery technology for that size of vehicle to be used in that way. When we move into the heavy duty sector, while there's work ongoing, it's not as mature, it's still slightly behind. So a lot of the questions the car sector maybe had 10 years ago, those are the questions that the heavy duty sector have today. And there are big constraints, but there are also massive opportunities if you want to look at it from the other perspective with respect to availability of power electronics, battery technologies, fuel cell technologies, and obviously the emergence of the hydrogen combustion technologies for that sector. Where there are gaps in the market in terms of product offering that can fill that need. But it also means from a research perspective, there's a huge amount to do. And from an economic perspective, there's huge business opportunities in that sector as well.
That's fascinating. And I suppose another issue that, how does all this fit together, I guess? I suppose I'm sort of thinking that it could be... It's good. I mean, obviously, you've already sort of said that people are beginning to work together across disciplines and all the rest of it, and work with manufacturers and researchers. So I suppose one of the other things I was reading about that you've been looking at is this Internet of Vehicles, isn't that? I'm just trying to remember the phrase, but which is a new phrase to me, I have to admit. So
this is kind of an evolution on from Internet of Things, which I think a lot of people are aware of. So when we were starting to have a think about how can we do things differently, how can we reimagine what our public transport sector might look like as things like smart cities come on board, sensor technology start to evolve, there was a lot of discussion around, well, we have a bus, which is one of the things which is, a integral part of our city centres. It's can we use those more effectively, not just in terms of the information that they receive from their surroundings, but also the information that they can harvest to be used in other ways. So in a similar way to the Internet of Vehicles, it's effectively the social network of vehicles where they are interacting with, sharing information, and then ultimately using that information to improve efficiency. So one of the things that we've been looking at, and I'm working with colleagues in civil engineering on this, is can we use the vehicles to monitor degradation on critical infrastructure? So start to look at using the routine routes that buses will pass over to, inspect road quality. Are we starting to see degradation in infrastructure that they're passing across? Harvesting sensor data and then using that to understand what's happening over a period of time so that we can start to improve some of the civil engineering predictive maintenance. So again, it's that disciplinary hopping. This is something that I don't think anybody would even have conceived of doing, 10 years ago. But those are conversations that we're now having is if we have those sensors, well, how could we potentially integrate them together? More widely, we're also then looking at can we control how energy is used on board the vehicle more efficiently and effectively by taking information from its surroundings. So if we know that there's heavy traffic on the horizon, if we know that there's an accident coming up, can we take that information on board the vehicle and then better utilize the energy on board so that we don't ending up with no battery power by the time we get to the end of the route. So the IOV, Internet of Vehicles, is really that notion of we have sensors, we have an increasing amount of sensors within our city centres, within our vehicles. How do we integrate those together? What valuable information can be extracted back out of those? And then trying to take that information and using it in a way that we can improve a service, improve service quality, and just ultimately, again, improving overall quality of life, be that by ensuring that roads are fixed before they start to degrade, or that we're ensuring that a service is sustainable because we're using the energy that's available to us in the most efficient and effective way possible.
So it sounds like not only clean but smart as well, and not only good for the environment but also good for the end user, the customers, the passengers, and so forth.
And I think that kind of bit around customers and ensuring that we're not just designing a vehicle which happens to be state-of-the-art engineering, using all the toys, bells and whistles. I mean, ultimately, at the heart of it, it needs to provide a service. There are passengers on board who need to be incentivized that this is not just an offering of public transport. This is the right way to get from A to B. This is going to be the most efficient, effective, and probably the most responsible way in terms of kind of managing their own kind of carbon footprint. So I think there's a lot in there about, the smart cities and how those vehicles operate within them so that they are the responsible right solution for the people who are trying to move around those cities.
I wonder if there was, in 30 seconds, if there's one list or one request that you could make of policymakers to move all this forward, what would it be?
That's definitely a big question, because I think kind of distilling that down to what's the one thing you would like. So I'm going to cheat and I'm going to go for two. I think the first one is very much lead by example. There is examples of government departments that are starting to practice what they preach. There was announcements earlier in April that central government fleets would be transitioned to zero emission by 2027, so that they were coming in ahead of the 2030 goals that they were setting. And I think that was a really key thing to do, because it demonstrates we're not just going to tell people what we're to do, we're also going to show you, and we're going to walk the path that we're asking everyone else to walk. I think that is key, both in terms of the leadership piece, but also for them to really understand the challenges that are going to come in underneath this. This isn't just a go buy 27,000 vehicles. This is 27,000 vehicles plus their infrastructure, plus the maintenance training, plus all of the other things that are going to come along behind that. The other side, and again, some of this is coming through the green prints, and this is where it's a slight cheat because it is one step on, is how do they incentivize that joint up urban planning so that you don't end up in a situation where policymakers are developing policy in isolation, where we have an energy strategy and a transport strategy. It needs to be one strategy for our urban environments, not multiple across multiple groups.
Absolutely fascinating, and plenty of food for thought there. I'll perhaps try to talk to some other people about some of those issues that you raise. But in the meantime, Professor Juliana Early, thank you very much.
Okay, thank you very much, Morris.
Many thanks to Professor Juliana Early of the School of Mechanical and Aerospace Engineering. Follow us on social media at QUB Engagement, and for more in this series, visit our website go.qub.ac.uk/charter-podcast, or subscribe to Queen's University Belfast, the Charter Podcast, on all the main podcast platforms.